Have you ever stopped to think about what really happens when you click on a bit.ly link? I mean, it seems so simple, right? But underneath that one little click is this massive, totally fascinating piece of engineering. So today, we're going to tear this thing apart and see what makes it tick. Yeah, it feels like a magic trick. You take a long, messy URL and poof, it's short and clean. But how does the system know where to go? And how does it handle billions upon billions of clicks every single month without even breaking a sweat? Well, that's the mystery we're solving right now.
So, in this explainer, we are going to peel back the layers on one of the internet's most common, everyday tools. We're going to look at the smart engineering decisions and the architecture that lets them turn a simple idea into a platform that can handle just incredible, mind-boggling scale.
Okay, first things first. Let's start with the part we all know, the core experience that this entire service is built around. This is the simple magic trick itself.
You've done this a million times, right? You grab some ridiculously long URL, you paste it in, and boom, out comes this neat, tidy little link. That simple transformation, that's the fundamental promise of the whole system.
So to pull this off, the system has to do a few key things. These are the non-negotiables. It has to take that long URL and give you a short one. It has to redirect you to the original when you click the short one. And, of course, it needs to handle nice-to-have features like custom names or even expiration dates.
All right, let's get into our first big technical hurdle. You see that little string of characters at the end of the short link? That ABC123 part? That is the key to everything. So how is it generated? And more importantly, how do you make sure you never, ever run out of new ones?
You know, this right here, this is the absolute deal breaker. If two different long URLs somehow ended up with the same shortcode, the whole system would just fall apart. Uniqueness isn't a feature, it's the bedrock of trust for the entire service. So how do they solve this?
Well, engineers have a couple of ways they could tackle this. One idea is hashing, but that comes with a small risk of collisions, where two different URLs could accidentally get the same code. The much safer, more reliable method is to use a sequential ID. Think of it like a ticket counter at a deli. Every new link just gets the next number in line. It absolutely guarantees every single link is unique. So, the winning strategy is to use one of those counters, but a special distributed one that's spread across tons of servers to handle the load. Then, they take that unique number and encode it using something called base62. It's basically a clever way to use every character you can, numbers, lowercase letters, and uppercase letters, to cram the most information into the smallest possible space. And what does this approach get you? Well, it gets you a number this big. 3.5 trillion. With just a 7-character code, you get over 3.5 times trillion possible unique combinations. That's a staggering amount of links, more than enough to last for decades without breaking a sweat. Okay, so you've got your unique shortcode. Awesome. But now you have to store it somewhere, and this brings us to the next monster of a problem, the database. We're talking about storing billions of links and handling an absolutely absurd amount of traffic.
The best way to think about this database is like the world's biggest, fastest digital filing cabinet. The shortcode is the label on the folder, and the long URL is the document stashed inside. When a click comes in, the system has to find that exact folder and pull out the document, all in the blink of an eye.
And this, right here, this is the one chart that explains everything about how this system has to be built. Way more people are clicking on existing links, we call those reads, than are creating new ones, which are writes. We're talking a ratio that can hit 1,000 to 1. The entire system has to be designed around this extreme imbalance.
So how on earth do you handle that kind of lopsided traffic? Well, engineers have a few brilliant tricks up their sleeve. They use sharding, which is just a fancy word for splitting that giant database into smaller, more manageable pieces. They create read-only copies to spread out the load, and maybe most importantly, they use aggressive caching, storing the most popular links in super-fast memory. It's like keeping the most used files right on your desk instead of running to the filing cabinet every time.
Okay, so let's put it all together. Let's follow a single click on its journey through the system. This is a real race against time where every millisecond is critical. So you click the link. Instantly, your browser pings the shortener server. The server does a lightning-fast lookup for that code, checking its super-fast cache first. If it's not there, it checks the main database. As soon as it finds the matching long URL, it fires back a response to your browser, telling it exactly where to go next.
But here's where it gets really clever. The server doesn't just send the link back. It sends a very specific type of instruction, an HTTP redirect.
And believe me, this isn't just some techie detail. This one choice is the foundation of their entire business model.
This system has to use what's called an HTTP 302, a temporary redirect. What that does is it tells your browser, hey, the thing you want is over there, for now. But next time you want it, you have to come back and ask me again. It forces the browser to check in every single time.
Now here's why that is so critical. If they used a different code, a 301 permanent redirect, your browser would just remember the final destination and go there directly next time. It would bypass their servers completely. But by forcing every click through their system with that 302, they can count every click for analytics, they can check if a link is expired, and they can even let the link's owner change the destination. A 301 would make all of that impossible.
And you can see how all these pieces are starting to click together, right? The unique codes, the hyperfast database, that crucial 302 redirect, they all build up to something much, much bigger than just a link shortener.
Suddenly, you're not just shortening links, you're building a whole platform. That core engine powers everything. Branded links on custom domains, QR codes, deep analytics, campaign tracking, even integrations with giants like HubSpot and Salesforce.
And you don't have to take my word for it. Listen to what Melody Park, a marketing lead at Smalls, has to say. For her team, the reliability and all the features built on top of that core technology made it an absolute no-brainer for their campaigns.
And that's really the bottom line, isn't it? These deep, thoughtful engineering decisions created a platform that serves as a critical connective layer between what people are clicking on and actual business outcomes. It's not just about redirection, it's about attribution and understanding.
It really makes you think. Behind these simple clicks and tabs that we do all day long, there's often this hidden world of incredible engineering. So my question for you is, what other everyday web tools are we all using that are hiding that same kind of amazing complexity?